Hey everyone, in this video I'm going to talk about the zero property of quadratics in factored form. Now before we jump into quadratics, let's just do a little quick background. The zero property is that the only number you can multiply by to get zero is zero, and multiplying by zero always gets you zero. So what that means is if you have two factors, or more factors for that matter, but let's just start with two. If you have two factors multiplying together and it equals zero, then that means that either your first factor equals zero, or your second factor must equal 0. So in this case of a times b, if a was 0, 0 times anything is 0. If b is 0, anything times 0 is 0. And those are the only possible values. So how does this apply to quadratics? Well, let's say we've got a quadratic like x plus 5 and x minus 3 equaling 0. The zero property says that one of these two factors, either the x plus 5 or the x minus 3, must be 0, because this is x plus 5 multiplied by x minus 3. So it's literally the same situation, but instead of just a simple variable here, we have a binomial. So if we break this down, x plus 5 equals 0, or x minus 3 must equal 0. Now from one-step algebra, the inverse of plus 5 is minus 5, so this ends up being x equals negative 5, or x equals 3. And those are the two possible values that make either of these factors equal to 0. If x is negative 5, then negative 5 plus 5 is 0, and anything times 0 is 0. Similarly, 3 minus 3 is 0, anything times 0 is 0. Okay, let's try one with slightly more interesting factors. Let's do 5x minus 2 times, let's do 3x plus 5. Why not? Okay, and we'll set that equal to 0. So this is the same idea. The algebra is just going to be a little bit trickier. We can either have 5x minus 2 equal to 0, or this other factor we'll do in a sec. So this negative 2 becomes positive 2 on the other side. So 5x equals 2. And then we need to divide by our coefficient. The inverse of 5 in front is a 5 underneath. So x is 2/5. Now this process of taking a factor and bringing the constant term to the other side and then dividing by the coefficient, we're going to be doing again and again and again in this course and in future years. So long as you're studying math, you're going to be doing this quite a bit. So we'd like to be able to do this. Essentially, we'd like to be able to jump right to this last step if we can. It'll save us a lot of time. Let's see if we can figure that out. So this positive 5, we know we're going to have to do the inverse of positive 5 when we bring it to the other side. So essentially the positive 5 is going to become negative 5. And the 3 coefficient in front we're going to end up dividing by. So we can actually just do that in one step. You take your constant term, and you flip its sign, because you're imagining bringing it to the other side of an equation, and then the coefficient you're imagining dividing by, so it goes underneath. And simple as that, you've got your second possible 0 in one step. Now, another way we can actually say this is, what are the zeros of a function? So let's do the zeros of the function f of x equals 4 minus x and 3x plus 2. Sorry, there, now you can see that. So 4 minus x and 3x plus 2. Okay, so this first factor, it's a little bit tricky now. We've got a negative sign in front of the x. So there's two ways you can think of this. You could think of this as bringing the 4 over to the other side to make it a negative 4, and then divide by the negative coefficient in front. So that would make it x equals negative 4 over your negative coefficient, which would make it x equals 4. The simpler way, though, which is kind of cool, is your x is negative. Just imagine bringing your x to the other side. So then you'd have positive x on the right-hand side equals positive 4. Either way, it doesn't really matter. You're going to get, in one or maybe two steps, your solution for this factor, which is x equals 4. And then this factor over here, x equals positive 2, if we bring it to the other side, is negative 2 over 3. And so that is the zero property of quadratics, and that is how you can find your zeros from vectored form.